Hey y'all, I wanted to do a little bit of polynomial and exponent properties review before your test coming up this next week. Hopefully you'll be able to watch this and answer any questions that you might have or any of those lingering misconceptions. Watch this video as many times as you need, stop, rewind. I'll also give you this worksheet if you want to work through it independently as well. I'll post that on the topics board. So the first couple questions that I have here, simplifying the expression. Remember, with polynomials, when we are simplifying an expression, all we're doing is combining like terms. Like terms happen when you have the same base or variable with the same exponent. So here, in this first example, notice that my variable is n. You'll notice that there's a bunch of n to the third powers. Now, before I get started, I do want to distribute this negative inside to turn all of those to their opposite. So I have 5 minus 6n to the third plus 2n to the third plus 2 minus 5 minus, actually, plus 8n to the third. So distribute that negative, rewrite the problem. Now let's combine like terms. Negative 6n to the third, 2n to the third, and 8n to the third. As I combine like terms there, I'm going to get 4n to the third, and then combine the numbers as well. 5 plus 2 minus 5 gives me a positive 2. So this would be my simplified expression. Number 2, same thing. I've got a couple negatives here that I want to distribute. So distribute that negative 1, distribute here, distributes 3 times. 7v to the third minus 8 plus 2v plus, how'd that become a triangle? V plus 1 minus 6v minus 7v to the third plus 2 minus 7v. Now notice here, I've got a v to the third and a negative v to the third, so those actually cancel out because 7 plus negative 7 is 0. Then I've got this 2v with this negative 7v, that gives me negative 5v. Oops, almost missed the negative 6v here, so that's actually a negative 11v. And then I've got negative 8 plus 1 plus 2 gives me negative 5. These other two examples here, this one's all addition. It's got 4 different terms, but there's still a lot going on here. Because it's addition, I don't have to distribute anything, so I can really just combine like terms. Look after the highest exponents first, so negative 4x plus a negative 6x to the fourth here gives me negative 10x to the fourth. Now let's go after the x to the thirds. So 3x to the third minus 5x to the third, negative 2x to the third power. Then the squareds, 2x squared minus 6x squared, negative 4x squareds. Then I've got this guy over here, negative 6x, all alone, so minus 6x, and then this positive 2, plus 2. For 4, same thing, just a lot going on where it's got a couple different terms here. So we've got 2 polynomials. Let's distribute this negative first, and I'll rewrite it after I distribute that negative. So 2n to the third plus 7 plus 3n minus 8n to the fourth minus 4n minus n to the fourth minus 6 plus 8n to the third. Now let's combine like terms. Go after the highest exponents first. Negative 8n to the fourth minus 1n to the fourth. Remember, there's a ninja 1 there. So negative 9n to the fourth. Next, I've got some n to the third. So 2n to the third plus 8n to the third gives me positive 10n to the third. Next highest exponent is the 3n here with the negative 4n, so that gives me negative 1n. And then my numbers, 7 and 6, negative 6, plus 1. So that would be simplifying our expressions here. Next that we're going to look at is finding products. So here we're working with distributive property. I'm taking this monomial and I'm distributing it inside of this binomial. It multiplies to each term here. Remember, one of our exponent properties, when you're multiplying bases, you add the exponents together. You're just multiplying the numbers in front and then adding the exponents if it has the same variable. So 2 times 8 gives me 16. X to the fourth times x to the first gives me x to the fifth. That's the first term. And then 2x to the fourth times a positive 8 gives me 16x to the fourth. For number 6, now I've got different variables. I've got an x and I've got a y. So I really just want to add the exponents when they have the same base. If it helps you, you can add the little ones above any variable that you don't see an exponent because there is a 1 there. Remember, it's like the little cousin of the ninja 1. So let's distribute this 3xy squared inside to both terms, the 4x and the 4y. So I get a negative 12x squared y squared. That y squared just comes along for the ride. And then negative 12, x just coming along, and then the y to the second times y to the first combined to make y to the third. For 7, now we're getting into binomial times binomial. This would be a problem where you either use FOIL or box method. For FOIL, essentially it's just make sure that each term from the first binomial multiplies to get to each term from the next binomial here. If you prefer box method, it just is the same thing. You're working with all the same terms. Negative 5x minus 5, and then down the side, negative 6x plus 7. So negative 5x times negative 6x is a positive 30x squared. Remember to add those exponents. Negative 5 times negative 6x is positive 30x. Negative 5x times positive 7 is negative 35x, and then negative 5 times a positive 7 is negative 35. Now this doesn't always happen. It's more of a like coincidence that it does occur, but oftentimes your diagonal here will be your like terms that you have to combine. So don't just leave your answer in the box. You actually have to write it out and combine like terms. So my final answer would be 30x squared minus 5x minus 35. Same thing for number 8 here. I'm dealing with negative 4k minus 3 times negative 3k minus 2. Let me show you FOIL on this one. So the first for FOIL is negative 4k times negative 3k gives me a positive 12k squared. Then I'm going to do negative 4k times negative 2 gives me a positive 8k. Then negative 3 times negative 3k gives me a positive 9k. And then negative 3 times negative 2 gives me a positive 6. Let's combine like terms here. I've got the 8k and the 9k, so 12k squared plus 17k plus 6. Boom. I also threw in another here for if I have a binomial times a trinomial. If you're doing FOIL, just be very careful to keep track of what you're doing here. Maybe you want to do the rainbows like one at a time. So if you have 7x times negative 4x squared, gives you negative 28x to the third. Then 7x times 6x gives you positive 42x squared. Then 7x times negative 3, negative 21x. Next, let's go to the negative 4. So negative 4 times negative 4x squared gives us positive 16x squared. Negative 4 times positive 6x gives us negative 24x. And then negative 4 times negative 3 is positive 12. Now we have to combine like terms. So it looks like it's a lot, but we're just combining with the x squareds here, the x squareds, the negative 21x, and the negative 24x. So my final answer, negative 28x to the third. plus 58x squared minus 45x plus 12. For number 10 here, I'm going to do box method to show you just the different layouts of this one. This one is going to be a 3 by 2 because I've got 3 terms over here, 3 and a 2. If you put it upright, so you have 3 rows with 2 columns, that would be fine as well. It still works out the same way. 4n squared plus 4n plus 7n minus 8. So each box is going to multiply here. So 4n squared times 7n gives me 28n to the third. 4n times times 7n gives me 28n squared. 7 times 7n, 49n. 4n squared times negative 8, negative 32n squared. 4n times negative 8 is negative 32n. And then 7 times negative 8, negative 56. The like terms here, I've got like terms on this one. And then I've got like terms in this diagonal to combine. 28n to the third minus 4n squared plus 17n minus 56. Now, on to exponent properties. Remember, there's a couple exponent properties that we have. So if you have the same base, you're adding exponents together when you are multiplying those bases. If you're dividing the bases, then you're subtracting the exponents. And then if you are distributing an exponent inside parentheses, you are multiplying those exponents together. And then we'll get to the 0 and the negative property in a couple problems here. So 2x to the fourth times 2x to the fourth, multiply the coefficients, add the exponents. That gives me 4x to the eighth. Pretty quick one. For 12, there's a couple different variables here. I've got x and y. I'm going to add this 1 here just to help myself out. So multiply the coefficients. I've got a 2, a 1, or a 2, and a 1 over here, that ninja 1. So that gives us 4. My x's, let's add those x's together. So I've got this 2 with this 3 with this 4. So 2 plus 3 plus 4 is 9. And then for the y's, I've got this 4 with the 1 with the 3. So that would give me y to the eighth. 4x to the ninth, y to the eighth. 13, again, add the exponents of the bases that are the same. I get 3x to the seventh and y to the first, or just y. Moving along. 14, now I'm getting into the dividing, and we see a negative exponent pop up here. I think the easiest approach first is to clean up this denominator. So let's clean this part up first before we try to move things around. So the top's going to stay the same, 3n to the third, over, multiply your coefficients. So 4 times 4 is 16. N to the negative fourth times n to the first. I add those exponents together, so I get n to the negative third. Now, let's think of this as a couple different things. So first, I've got my coefficients here. Think of it as like you have a fraction, 3 over 16. That fraction won't simplify, so my answer is going to have 3 over 16 in it. Now with my variables, I want to get rid of negative exponents. I don't like negative exponents, so I'm going to bring it up to the numerator here to make it positive. So that has n to the third, that was already there, and then that n to the third comes up top. So when you bring it up, you're making it a positive n to the third. And then to finish this off here, it'd be 3n to the sixth over 16 as a final answer. For 15, a couple different approaches. I might just distribute this -2 into the parentheses first. Some people might look at this as this whole thing being negative, so they can drop it down to the bottom. You're certainly free to do so, but I'm going to distribute first instead. So I have n to the 6th over 2n squared. Now that I've got both the numerator and the denominator simplified, I look at my variables. I've got n to the 6th over n to the 2nd here. So when you are dividing bases, your exponents are going to subtract. So think of this as I've got 2 n's on the bottom and 6 n's on the top. If I take away those 2 n's on the bottom and 2 from here, that gives me 4. So that means I have n to the 4th over 2. There's distributed property on both the top and the bottom, as well as 2 different variables. So this 3 goes to the 4. There's also a 1 on this x, so the 3 goes to the 1. And do not forget, the 3 is going to distribute to the 2 as well. Same thing on the bottom, 2 to the 4, 2 to the 3. So we get 2 to the 3rd, x to the 3rd, because 1 times 3 is 3, and y to the 12th. You multiply the exponents here, over x to the 6th, y to the 8th. Let's simplify this a little bit more. 2 to the 3rd is 8, because it's 2 times 2 times 2. It's not 2 times 3. It's 2 times 2, 2 times 2 times 2. So that is 8, x to the 3rd, y to the 12th, over x to the 6th, y to the 8th. Let's simplify our variables now. 8 is going to stay where it's at. Nothing's going to cancel out with it. I've got x to the 3rd over x to the 6th, so I've got 3 on top and 6 on bottom. So if I take away all 3 of these and 3 from here, that gives me x to the 3rd in the denominator. And then I've got y to the 12th over y to the 8th. So I've got 8 on the bottom that I'm going to take away from 8 on the top. Gives me 4. So y to the 4th. 8y to the 4th over x to the 3rd. 2 more problems to go here. So this one is a doozy. I am distributing a negative exponent. So let's distribute here to here to here. And we'll come back to the denominator here in a second. So when I distribute, I get 2 to the negative 2nd, x to the negative 8, and y to the positive 4. Now, in the denominator, you see that there's a couple 0 exponents. When something has an exponent of 0, it's always going to be 1. So this y to the 0 here and y to the 0 here, they're both going to become 1. So this essentially becomes 2 times 1 and 2x to the 3rd times 1, which, I mean, times 1 in anything is just going to stay what it was. So I have 2 times 2x to the 3rd, which gives us a 4x to the 3rd. Now let's look at the numerator here. So 2 to the negative 2nd. If you type that into your calculator, it's going to give you a fraction or a decimal. Let's think of it instead as being something that we would treat like the x to the negative 8 here. I'm going to drop this into the denominator. So I'm going to do the same to the 2 to the negative 2nd. So doing that, y to the 4th stays in the numerator, and we're going to drop this down. So I have 2 squared, x to the positive 8 now, and then times 4x to the 3rd. Now that that 2 squared is in the denominator, we look at it as, oh, well, 2 squared is 4. So let me just erase this, and I'm going to replace it with a 4, because 2 squared is 4. So let's combine these like terms here. So my final answer, y to the 4th over 16x to the 11th. So don't worry if you get a negative exponent on a coefficient, because you can still drop that into the denominator and turn that exponent positive. And then finally here on 18, distributive property again, so the 3 to the 4 and the 3 to the 2. We can also clean up this denominator kind of in one step here. So I get 2 to the 3rd, u to the 12th over 2 times 1 is 2. There's 1 on both of these v's, so v squared, and u to the 7th. Now 2 to the 3rd again is going to be 8, so it's 8 u to the 12th over 2 v squared u to the 7th. Again, looking at these coefficients, treat it like you would a fraction. What is 8 divided by 2? It turns out to be 4, so this is going to be 4 over 1. My u's, I've got 12 on top and 7 on the bottom, so if I get rid of these 7 here and take away 7 from here, it becomes 5. So u to the 5th in the numerator, and then v didn't have anything to change with, so I get 4u to the 5th over 1v squared as my final answer. So hopefully this video helps you clean up any confusion that you might have with our polynomials, simplifying expressions, multiplying the distributive property, and then all of our exponent rules. I quickly went through those. Please reach out to me if you have any questions. Again, I'm going to post this worksheet if you want to kind of follow along in the topics board, so go take a look at that, and good luck with your studying.